Hello students, all right, so today I'm going to cover, right now I'm going to cover week 2 materials, okay, and as I mentioned before for week 1, um, I'm going to extend quiz number 2 so that you can retake it since you didn't have the resources, all the resources available to be successful. So anyway, so let's get started. Um, I'm just gonna pick randomly some problems, and we're gonna cover that from there. All right, so let's get started with the mixed number and how to write a mixed number as an improper fraction, right? So here we have um, 7 uh, and 6/7, right? So basically, if I want to write this as an improper fraction, so I'm just going to rewrite it here, right? The first thing you have to do is take the denominator of the fractional part, multiply by the whole part, so multiply, and whatever you get, you need to add the numerator of the fractional part. So you add here, okay? So basically you're gonna have 7 times 7, 49, and then plus 6, 55. The 55 is going to become the numerator of the improper fraction, and the denominator remains the same. So 55 over 7 should be your answer. Okay? All right. So let's move on. All right. So same thing for this. All right. So let's do the other way around. Let's do 28 divided by 5. There's different ways that you can do it. Let me see the next one. Yeah. So we're going to do 2 of them. So let's do this one. So here we have 28 over 5, right? So I need to go from an improper fraction to a mixed number or whole number if it's possible. But here it's going to be mixed. All right, so you can do the long division. And here you have 28 divided by 5, right? And so you go through the process. I'm going to tell you how to, once you finish with that long division, I'm going to tell you the parts that you need to set up your mixed number. So here you have 5, goes how many times into 28? It goes 5 times, right? And then you get 25 here. You subtract 25 from 28, and that's 3. Well, 5 doesn't go into 3, so we stop here. So 3 is your remainder. We're going to call 5 here. That 5 here is the quotient. And the 5 here is the divisor, right? All right. With all those information here, quotient, divisor, and remainder, how do I set up my mixed number? Well, the quotient is going to be your whole number part, right? So it's going to be, so let me put it like this. So whole part's going to be here. Then the fractional part is going to be the remainder, right? Over the divisor. Okay, so that's pretty much the setup. And so the equivalent of 28 over 5 should be 5. And the remainder is 3 over 5. So you can kind of go back if you want to verify yourself again. 5 times 5 is 25. 25 plus 3, 28. That's what we got here over 5. And that's it. That's when you're using long division. Now let's try another way, and that way I'm gonna use a calculator. So a combination of a calculator and mental calculation. Okay. So basically, first, so we know that the mixed number there's going to be some value for the whole number part. And then you have the remainder here. And then we have the divisor, which is the same thing as this one. So we can put it here. How do we find this whole number part using 126 over 7? So you're just going to use 126 divided by 7. So 126 divided by 7 in your calculator. So if you use your calculator, let me choose another one, because 126 divided by 7 is 18. So that's not what I wanted. I want to show you how to convert an improper fraction to a mixed number, but that doesn't end with a whole number. Okay, so let's try another one. Okay, so forget about this one. Let's say 131 over 7, for example. Okay, so now we have the fractional part here, right? And then we have the whole number. So let's say we have 131 divided by 7. What's going to give us? Okay, so 131 divided by 7. That gives us 18.71 and some change, right? So I'm just going to put 18.71 42857, and then it continues on, right? All right, so the only thing that we need from this answer here is the 18. And the 18 is going to be your quotient part, or that whole number part. So let's put 18 here. And then the only thing that you have to do is to figure out that numerator. And that's easy, because now you know the whole number part. So now you can do 18 times 7, right? So 18 times 7, and that's 126, right? So 126. So because the numerator here is 131, all we need is the difference between 131 and 18 times 7, which is 126. And that's what? That's 5, right? So that's it. So 18 times 7 is 126. And because the numerator here is the difference between this product and the 131 here from the improper fraction, then that's going to be 5, right? So 18 times 7 is 126 plus 5, 131, and that's your mixed number. Okay, so hopefully you remember both ways of finding your improper fraction from both ways of finding your mixed number from an improper fraction. All right, moving on. All right, so and you can do the same thing with those. Okay. All right, so here we want to write the fraction in its simplest form, right? So let's start with this one here. Why not? All right, so we want to simplify this. How do we do that, right? So let's not forget the fractional bar is a division, right? So basically, I can, what we want to do is maybe find common multiple, right? On top and at the bottom of 240 and 272. Find common multiples, right? And so, for example, let me see. If I do 240, so we know that 240 is divisible by 2, right? And also 272. So let's try that. So I have a 240 divided by 2. That's going to be 120, right? So basically, I'm saying that 120 times 2 is 240. Okay. So I want to do the same with 272. 272 divided by 2 is what? 136, right? So it's 136 times 2 is 272. Okay? So if I'm using the fractional bar, 2 divided by 2 is equal to 1 over 1, right? So I've simplified. Now I'm left with 120 over 136. Well, I'm not done because I know that 120 and 136 are still divisible by 2. So let's divide by 2 again, or we write that as 60 times 2 is 120. And that's 68 times 2 is 136. And again, 2 divided by 2 cancel out or reduce itself to 1. And I'm left again with 60 over 68. Okay? Let me see some things. Okay, so now, let me see, 68 divided by, yeah. So let's do again. Let's divide this by 2 again, right? Or just rewrite this as 30 times 2, and then here, 34 times 2, right? And we get 2 divided by 2 again, that's 1 over 1, equal to 30 over 34. And then, it seems like it's still divisible by 2, so I can write this as 15 times 2, and the bottom one by 17 times 2, right? And it's 2 divided by 2, and we get 15 over 17, right? 15, there is no common multiple that's going to divide 15 and 17, right? So that's going to be my final answer. So he's saying, well, it's a long process. Well, unless you know a value, so you just know. So I'm showing you the long way so that you can kind of, not getting stuck of finding the greatest number or the greatest common multiple between those two values. Just start with a 2 or a 3 and then work your way down because your goal is to get the right answer. Okay? So that's how you will simplify a big value like this. There are some other ways, but you can use a simple way of doing things. Just divide by 2 or divide by 3 until you get to the prime numbers. All right. Or not prime numbers, but where you get to where you cannot simplify it anymore. All right, so here we want to determine whether a pair of fractions are equivalent. Well, that's kind of easy. Equivalent means that a is 5 over 9 equal to 20 over 36. All right, so we need to determine that. How do I do that? Well, there's a cross multiplication, right? So you can do cross multiplication in order to check if two fractions are equal to each other, right? So basically, and it's kind of a proportion trick that you can use. So if I have a over b equal to c over d, right? If I cross multiply, that means that a times d must be equal to b times c. Okay, so that's all we're trying to do. If these two are equal to each other, that means the fractions are equivalent. So let's try. So here I have 36 times 5, right? So I'm cross multiplying, and 9 times 20. Okay, that's 6 times 5 is 30, 15 and 3, 18, that's 180. And this is 180 equal to 180, so therefore they're equivalent because you get the same answer here. That's it. That's all you have to do when you have to determine whether a pair of fractions are equivalent, equal to the same thing. All right, and you can do that on your own if you wish, but that's it. Okay. All right, so finding prime factorization. So let's prime factorization. So you have, in order to find the prime factors of 198, you can use a factor tree, right? So you have 198 here, and then you start a factor tree. So you choose any two factors. I'm sorry, my phone. All right. Any factors of 198 where it's equal to 198. So, for example, 2 times 50 and 49, 99, right? 2 times 99, right? Well, 2 is a prime number, so I stop here. So that's my first prime factor, right? Then I can break down 99. I can say, well, 99 is not a prime factor because I can say this is equal to 9 times 11, right? 9 times 11. 11 cannot be broken down further, so 11 is a prime factor. So I'm circling it. 9 is not a prime number, so I need to break it down as 3 times 3. And that's it. 3 and 3 are prime numbers or prime factors, and I am done. So that means that 2 times 3 times 3 times 11 is equal to 198. Okay? So, let me write 198 here. Okay, so how do I write that? So, basically, I have 2 times 3 times 3 times 11. That's 198. But here, usually when you put when you want to represent prime factorization, if you have repeated multiplication, you put it as a exponent. So here, instead of writing 3 times 3, we're going to put 3 to the second power times 11. And that's it. That will be your final answer. Okay. All right, so let's move on. All right, so now let's do some operation. Okay, adding, subtracting, dividing, multiplying. All right, so here we have, I'm sorry, perform the indicated operation. So when you're dividing, so this is 3/4 divided by 6/7. All right, when you're dividing, the trick here is to rewrite that division as a multiplication, right? So to divide in a fraction is to multiply its reciprocal, meaning that if I have a over b divided by c over d, then you need to rewrite it as a over b times the reciprocal, so reciprocal of c over d. And the reciprocal of c over d is d over c, right? So I go from division to multiplication, and then from c over d to d over c. Okay, so here I'm going to write this as 3/4. So the first fraction does not change. The division becomes multiplication, and 6/7 becomes 7/6. That's it. Now, for multiplication, you just multiply across. Numerator times numerators, denominators with denominators, and you get 21/24. And then if you want, you can simplify here, right? You can divide by 3. 21 divided by 3 is 7, and 24 divided by 3 is 8. So 7/8 is your simplified form of this operation. Okay? All right, so let's move on. So this one is interesting because I see a lot of people making mistake here with those type for whatever reason. All right, so here we have 3/4 times 6. And a lot of people, not a lot, really, but some people will just multiply the 6 with the 3 and the 6 and the 4. Wrong. Cannot do that at all. The 6, which is a whole number, will just be multiplied by the numerator, right? So the 3/4 multiplied by 6 can only be multiplied with the numerator and you keep the denominator as it is. You may view the 6 as 6 over 1. It will be the same thing. 6 divided by 6 is 6. If you want to put it that way, then it might become easier for you. And then now you get 3 times 6, 18. And then 4 times 1, 4. And then you can simplify from there. You divide by 2 here, divide by 2, and you get 9 over 2. Okay? So that's that. So be careful. A fraction multiplied by a whole number, right? You want to make sure that 6 is not being multiplied by the denominator, because the 6 is really a numerator, right? Okay. All right. So same thing here. Well, this one, so you have 20 divided by 4 over 3. So 20, you might want to write it as 20. Oh, let me put the. You might want to put it as 20 over 1 divided by 4 over 3 first. And then you write it as a multiplication. The first fraction never changes. So it's 20 over 1 times 3 over 4. And then you multiply across. You get 60 divided by 4. Or 60 over 4. And then 15 will be the answer. 15 over 1 or 15. Okay? Let me do another one here. Yeah, this one, for example. So here you have a mixed number. 1 and 4/5 divided by 1/5. Right? So first, you want to take care of this and change it as a improper fraction. Right? So 5 times 1 plus 4, that's 9 over 5. Divided by 1 over 5. Okay? So if you have an improper fraction, change as an improper one, then proceed. That will be an easier path. Okay, so now I can change it as a multiplication. So 9 over 5 times the reciprocal of 1 over 5, which is 5 over 1. Then you can multiply across, and you get 45 over 5 times 1, 5. And that gives you 9. 45 divided by 5. Okay? All right. That was multiplication and division. All right, so now let's kind of move on. So I want to, okay, the addition and subtracting is coming up. Okay, so let's do some comparison or finding the least common denominator. Let me see if we can. Okay. All right, so this is kind of an extension. I mean, you should be able to do that, right? Finding the area, you multiply, the sides if you want to find the area. The length times, it tells you right there. So it's 22 over 5 times 1 over 2. And then you answer, and that's going to give you 22 over 10, right? And simplify this if you can. That's going to be 11 over 5, right? Because divide this by 2, divide this by 2. That's 11 over 5. I don't see an 11 over 5 anywhere. So they made a mistake, because I know, unless I'm seeing something wrong. 22 times 1, we're finding the area. That's 22 over 5 times 1 over 2. Yeah, 22 times 1 is 22. And 5 times 2 is 10. Divide by 2, you get 11. Divide by 2, you get 5. So they probably made a mistake. It's probably a typo. It happens with the test generator. I don't see. So 11, yeah. So 11 over 5 square foot, I'm sorry, is the right answer in this case. No doubt about that. If you want to dispute me, just gotta prove you gotta prove it to me. So get on YouTube and show me that it is one of those, but I'm sticking to the 11 over 5. So it does happen when you do a test generator and you get the wrong answer. All right, so moving on. All right, so all those are word problems that we've done in week 1, but now involves fractions, right? So let's do this one here. On the recent trip, Asha drove 268 miles on a 12 and 1/6 gallons of gasoline. How many miles per gallon did she average? Okay. So how many miles per gallon did she average? So you have to do a division. So basically, you have, so this one is, this one is a good one. So you have 268 over 12 and 1/6. So this one is a very good one that we can do. Okay, so this is a division of a whole number. So you can rewrite this as 268 divided by 12 and 1/6. Just give me a sec. All right, so 268 divided by 12 and 1/6. Change this as a improper fraction and change this into a fraction, which is also improper fraction. So we write it as 268 over 1 times the reciprocal of that improper fraction. Let me put that improper fraction here. That's 72 plus 1, 73 over 6, right? That's 73 over 6. So if I multiply by the reciprocal, which is this here, that's going to be 6 over 73. Okay, so 6 over 73. And so multiply across. So what is 268? 268 times 6 is 1608 over 73. Okay, but I don't want to leave it like that. I'm going to change that into a mixed number. So remember when we used the calculator, right? So we say that, you know, that whole number here is going to be whatever we get from 1608 divided by 73, the values in front of the decimal point. So let's do that. So 1608 divided by 73 is equal to 22.002. So 1608, I'm just going to write it here, divided by 73 is equal to 22.02739, and then whatever. But we're only interested in the 22. The 22 is going to be right here. Okay, so now all we need to do is do the product of 22 and 73. Obviously, that's going to be a number that's going to be close to it's going to be close to 1608. And all we have to do is take the remainder, the difference between those two values. So it's going to be 1608 minus, what is 22 times 73? 22 times 73 is 1606. And that's 2. So that's going to be 2. So 22 and 2/73 miles per gallon is going to be your answer, and it's right here. Okay? All right. So we are moving on. Okay? So let's move on to finding the least common multiple. All right, so the least common multiple of two numbers is obviously we have to kind of find all the multiples of those two values, right? So if I'm looking at 18 and 9, you know, a lot of people get confused on what are the factors of 18 and 9, and they'll say, oh yeah, it's 9 or 2 or 3, whatever the case may be, but it's not. There is a difference between factors and multiple. So for example, 18, the multiple of 18 is 18 times 1, 18. 18 times 2, 36. 18 times 3, 54, and so on. And then that's the multiple of 18. Okay. Now, if I want the multiples of 9, it's going to be 9 times 1, 9. 9 times 2, 18. 9 times 3, 27. 9 times 4, 36, and so on. Right? But now, I'm pretty sure that we have many common multiple, right? So we have many common multiple between those two values, but what we're looking for is the least common multiple, right? So we're looking for the least one, and 18 and 18 are the least common multiple. Those are the LCM, 18 and 18, right? Not 36 and no other ones, 18. So that's it. That's how you find the least common multiple. Okay, and you will do the same thing for 9, 48, and and 162. But for 948 and 162, there's another way that you can do it. Is by finding first the prime factors, and then I'm going to show you how to find the least common multiple. Okay, so for 9, it's just 3 times 3, right? So it's 3 squared, right? So 3 squared. That's going to be for 9, right? For 48, let's figure it out. That's 12 times 4. 12 times 4, 8 times 6, 16 times 3. 16 times 3. Okay. 16 is the equivalent of 2 to the power 4 and times 3. Right? So 16 times 3 is 48. For 162, so I can do a factor tree here for 162. It's that's 81 times 2, 9 times 9, or 3 to the power 4. So 9 times 9, or 3, 3, 3, and 3, right? And then you have the 2 here. So it's really 2 times 3 to the power of 4. Okay? And that's it. Okay, so how do I find my least common multiple between all of that? Okay, so all you have to do is select the bases that are in common, right? For the 2, you look and you take the one that has the highest exponent, which is 2 to the power 4. And then here again we have the common bases, 3, 3, 3, and then you select the one that has the highest exponents, which is 4 here, 3 to the power 4. So basically 2 to the power 4 times 3 to the power 4, which is 16, times 81 will be equal to, so let's see how much it's going to be. I mean, what will be the value? 16 times 81 is equal to 1296. 1296. That's one way of doing it. Okay. I mean, when you have large numbers or you have multiple values where you have to find the least common multiple between them, then you might want to put it like this and put them in prime factorization notation. Okay. All right. So this one here, you have to determine if 7 over 16 is less or greater than 3 over 4. So the only thing that you have to do here is to convert those values or those fractions into decimal numbers, and then you'll find out. So what is 7 over 16? So 7 over 16 is 0.4375, right? 3 over 4 is 0.75. So if you the value that is close to the decimal point, which is the 4 and the 7, if you compare them, whichever one is greater, that's the one's going to be, that's, that one 0.75 is greater than this. So therefore, I'm saying that 0.4375 is less than 0.75, right? So I don't really care about the rest because I'm comparing the 7 and the 4, right? So that's how you handle those comparison. Okay, same thing here. You will do the same thing. All right, so now let's get to addition and subtraction, and then we will be pretty much done. And okay. All right, so let's start with adding and subtracting fraction that have the same denominator. Right, so that is easy because when you're adding, the denominator do not change. The denominator does not change. So all you're doing is adding the numerator, 3 plus 3 over 8. So you put it as a single denominator, and your answer will be 6 over 8. But when you simplify, you divide by 2 here, divide by 2 here, you get 3 over 4 as your final answer. Okay? Let's look at another one. Same thing here. You have the same denominator. So you're going to do 7 minus 5 over 21. 7 minus 5 is 2 over 21. There is nothing else for you to do. That's going to be your final answer. Okay? Now we have addition of two fractions with different denominator. All right, here's what you cannot do. Is do 3 plus 2, 5, and do 4 plus 5, 9. This is unacceptable. That means you didn't read anything. You didn't do any type of research into doing things, right? You cannot do that, right? For multiplication, you can multiply the numerator with the numerator, denominator with denominator. For multiplication, not for addition nor subtraction. Okay, that's been established. Now, how do we do this? Well, first, we need, in order to add any fraction, you have to have the same denominators. So, what we have to do is to find an equivalent fraction with same denominator, right? That's the goal. All right. So the first thing I have to do is to find the LCD of 4 and 5. So find the least, well, we talked about the least common multiple, right? The least common denominator and the least common multiple are the same. Okay? So you find the LCD, or if you want to call it LCM, of 4 and 5, right? And in this case, it's just 20, right? Because 4 times 5 is 20. All right, so I want to find an equivalent fraction of 3 over 4 that has now a denominator of 20. How do I do that? Well, I know that to get from 4 to 20, I need to multiply 4 by 5. And so to get an equivalent numerator now, I need to multiply 3 by 5. And I get 15 over 20. And then 15 over 20 is exactly the same as 3 over 4. If you were to simplify 15 over 20, you will get 3 over 4, right? So we're going to replace 15 over 20. We're going to replace 3 over 4 with 15 over 20. Now you do the same thing with 2 over 5. So 2 over 5, we want an equivalent fraction with a denominator of 20. And then you ask yourself, well, what do I do to get from 5 to 20? All I have to do is multiply by 4, and I get 20. So therefore, I have to multiply 2 by 4 to get 8 as a numerator. And that's it. You have your equivalent fraction that's going to replace 3 over 4 and 2 over 5. So let's replace them. So I have 15 over 20 plus 8 over 20. Okay, now I have the same denominator of 20. I can only put like that common denominator of 20, and then I just add 15 and 8, which is 23. So 23 over 20 is your answer. Okay? All right, so let's move on. Let's do maybe a subtraction. Okay? So let's find 9 and 12, right? I cannot do 9 minus 12. That would be completely wrong. So we need to find an equivalent fraction for 7 over 9 and equivalent fraction for 1 over 12, right? But let's find the LCD of 9 and 12. Okay, what are those? Well, let's see. I think it's 36. Why? Because 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, and so on. Let's say for 12, 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, and so on. But we can see that 36 is the least common multiple, or we can call it least common denominator because we're talking about two denominators. All right, so now I want 7 over 9 to have an equivalent fraction with a denominator of 36, and now the numerator should be different. So how many times 9 goes into 36? We know it goes 4 times. So therefore I need to multiply the top part by 4, and it gives me 28 over 36. 28 over 36 is the same thing as 7 over 9. Now I'll do the same thing for 1 over 12, and I want it to have an equivalent fraction with a denominator of 36. And how many times 12 goes into 36? 3 times. So therefore I need to multiply the top by 3. So I get 3 over 36. 3 over 36 is the same thing as 1 over 12. I'm going to replace these two here. So I have 28 over 36 minus 3 over 36. Beautiful. Now I have a common denominator of 36, since they are the same. And then I do 28 minus 3, which is 25. And 25 over 36 is my answer. All right. Now, if this process is too much for you, here's another trick. Let's try this one. So I have another little trick here that is very elementary. 1 over 8 plus 4 over 13. So now we're not even looking for an equivalent fraction, right? We just straight up. So whether you're adding or subtracting, here's what you can do. You can find a common multiple, a common denominator, by just multiplying the denominator. You just multiply them. So let me put some color in it, right? You just multiply them. right? So you have 8 times 13 is 104. That's going to be your common denominator. 8 times 13 is 104. And then I'm going to cross multiply the 13 with the 1. And then the 8 with the 4. And you keep the operation sign. So it's going to be 13 times 1. So I'm just going to write it out so you know where it comes from. 13 times 1, right? In parentheses, plus, that's the plus here, 8 times 4. 8 times 4. Right? So when I evaluate that, I get 13 plus 32 over 104. And that gives me 45 over 104. And that's it. There's no common multiple between those two. So 45 over 104 is correct. And everything that we've done so far, all those addition and subtraction, you could do it the same way, except for the ones that have the same denominator. You don't want to do that. Just for the ones that have different denominator. Like for example here, you want to do 9 times 7. That's going to be 63 as a denominator. And then you do 7 times 7, 49, minus 9 times 3, 27. And that gives you 22 over 63. Okay? So that's, let me see. Okay. Okay, so that's about it for adding and subtracting. You can do that with fraction with mixed number too. Let me show you how you can do that. So we did those kind of things here. Let's say we have it has the same fraction. Let's say we have these two, right? So I mean, let's say this is 11 and 2/3, right? So I'm just making up, right? So you don't want to do the the setup and stuff like that. You just want to put like 11 and 2/3 minus 7 and 2/5, right? All right. So the first thing we want to do with mixed numbers is to turn them into improper fraction. Don't try to be a hero and no. Just turn them into improper fraction. So 11 times 3 plus 2 is 35 over 3 minus 35 plus 2, 37. That's 37 over 5. Beautiful. Obviously, we're not going to have the answer here, right? So, because I just made that up here. All right, so multiply the denominator. It's 15. So that's your common denominator. So you cross multiply. You get 35 times 5. 35 times 5. 175. Right? 35 times 5. Minus 37 times 3. Right? So 37 times 3. That's 111. And that gives you 64 over 15. And usually, if they giving you operation with mixed number, you want the result as a mixed number. So you do 64 divided by 15. 64 divided by 15. You get 4.266. We only need the 4. So it's going to be 4 with a denominator of 15. 15 times 4 is 60. So the remainder would be 4, because 64 minus 60 is 4. So that's it. That's how you handle those additional subtraction with mixed number. Turn those mixed number into improper fraction, and then use the common multiple, just multiply the denominator, and then kind of cross multiply the numerator with their adjacent denominators, and go through that process. Okay? Alright, so I hope this was helpful. The rest is pretty much kind of the same thing here that we've done earlier. I think it's a kind of repetition of what we've done, yeah. And so, yeah. Alright, so that's it. Okay, so like I mentioned, I'm going to extend week 1 and week 2, so that you can kind of make up certain things, and we'll go from there. All right, take care.